Hey, everybody, and welcome back to another episode of Adventures in Machine Learning. I'm your host, Charles Max Wood, and this week we're talking to Miguel Morales. Miguel, do you want to say hello and introduce yourself real quick?
Hey, everybody, Miguel here. So I work as a research engineer at Lockheed Martin, missiles and fire control, autonomous systems. I'm also a part-time instructional associate at Georgia Tech. I teach the course on reinforcement learning and decision making, the master's course, and I'm the author of Grokking Deep Reinforcement Learning. So I'm happy to be here.
When I went freelance, I was still only a few years into my development career. My first contract, I was paid $60 an hour. Due to feedback from my friends, I raised it to $120 an hour on the next contract. And due to the podcasts I was involved in and the screencasts I had made in the past, I started getting calls from people I'd never even heard of who wanted me to do development work for them because I had done that kind of work or talked about or demonstrated that kind of work in the videos and podcasts that I was making. Within a year, I was able to more than double my freelancing rates, and I had more work than I could handle. If you're thinking about freelancing or have a profitable but not busy or fulfilling freelance practice, let me show you how to do it in my Dev Heroes Accelerator. Dev Heroes aren't just people who devs admire, they're also people who deliver for clients who know, like, and trust them. Let me help you double your income and fill your slowdowns. You can learn more at devheroesaccelerator.com.
Wow, you sound way smarter than I am.
Not that much. It works. You got to work a lot to actually, get through in this thing, but it's not the brains.
It's not the brains, it's the persistence, huh?
Yeah. Well, I mean, if you like it, I'm sure that you know a lot more about audio equipment than me.
Yeah, maybe. But yeah. So anyway, we're going to talk about reinforcement learning. And I kind of, when we get into these topics, like to start at the basic level, right? So why don't we start out with what is reinforcement learning?
Yeah. So the way I like to see reinforcement learning is a sort of, so the solution to the artificial intelligence problems, a proposed solution. And this solution in particular tells you that, well, there's it's something that you can intuitively understand, which is that living creatures usually go after things, right? After rewards. They have a purpose, right? We call it in reinforcement learning a reward, right? So the idea of reinforcement learning is like, how do we model this kind? And we can get philosophical about that, but the bottom line is, how do we get a similar paradigm of learning so that beings, not humans or not animals, but artificial, can have an incentive, a desire, something that they want to go after. So in reinforcement learning, the idea there is that you reinforce the agent by giving it rewards. People sometimes call it punishment, but negative, positive, but just a numeric signal that is delayed, that is uncertain. You don't know what you get. You try to go after something, but intelligent agents learn to balance that kind of short-term reward in order to obtain the longer-term rewards, right? So when you invest, right, some money, you go like, well, I don't know. I don't want to put $1,000 in this bank. Well, why would I do that? I'd rather have the $1,000. Like, you put it and then you watch it grow, or sometimes goes down, but you got to, kind of relax a little bit and then wait until it goes back up. And that in society, we usually see folks that can successfully balance those kind of short-term rewards for traded off with a long-term values and rewards as the smartest guys, right?
Right.
You were able to defer instant gratification and go after the big thing. And reinforcement learning is basically the same thing. So reinforcement learning kind of gives you a way to model basically any problem, virtually any problem that you can think of. You can model it for reinforcement learning. And then it also gives you, a bunch of algorithms and, strategies and things that you kind of start learning. Okay, so these are better agents than this and so on. So that's, I think, a good way to introduce reinforcement learning.
Right. It sounds like, to me, like training a dog, right? My sister was going through this the other day with us because she just moved back in with her in-laws, and they have, what was it? It's a bigger breed of dog, a Labrador puppy, right? And so it's like a year old, but it's a lot bigger than her 2-year-old, right? And so it'll just run him over, right? It's just like, hey, let's play, and he's so, and he wants to play with you. And so he's jumping up on you, right? And so, they took him to a training thing. And then from then on, yeah, she'd sit down, right? And so he'd sit down and she'd give him a treat, right? And then, get off the couch. And so, he'd get off the couch and she'd give him a treat, right? And so after a while, then you have this good behavior from this dog and it's just automatic.
Right.
Does that make sense?
Yeah. And the dog, after that, you don't need to give it a treat anymore. The dog goes after the sort of quote unquote long term, or the okay, my owner is happy and everything is good. This is all good, right? Of course, a pat is always good, but good boy is always good, but it's not required. Yeah.
Right.
Yeah.
Very cool.
Yeah, exactly like that.
So how do you do this for computers, right? Because boy, if I could give my computer a treat and get it to do what I want, that would be easy. But this seems like it might be a little bit more complicated than that.
Yeah. So I think the way to go about this is, okay, unfortunately, these AI agents are not, huge black boxes that we just put stuff in and, out comes the smartest thing in the world.
Right.
When you see success stories such as AlphaGo, very popular, or, Open5 from OpenAI, Alpha Star, all of those, cool things. You know what? They cannot figure out, like, AlphaGo is not able to play StarCraft, period.
Right.
And AlphaGo is the best at Go. I mean, and that's a very complex game. Like, that's kind of sad when you think about it, because I think I could play decent StarCraft and decent Go. Well, not quite, but chess maybe. But, the point is they're really not general the way that we would like to, right? So the way to create such a solution to a problem is first to actually model the problem. And there is such a, there's, something called Markov decision processes. And they kind of give you a kind of blueprint as to what an AI of this kind needs, and, what are sort of the conditions and the assumptions for best learning, for them to learn, good. And then, the way to go about this is just you basically follow that, that blueprint, and you can create environments that do things, right? And, in fact, I mean, I unfortunately cannot talk about the details, but that's what I do in my full-time job, right? So,
right.
Lockheed Martin. So you basically try to create environments that an AI agent will be able to interact with, and, explore different things, and then learn how to solve your problem. Now, these agents are not general enough in some sense. They're general enough in some other sense. And I know that's kind of confusing, but, the thing is that the same agent, you can train, well, there's some conditions, but you can train some of the same agents in different problems, as long as you model other problems in quote unquote their language, right?
Right.
And their language is it's pretty obvious. It's like they need an observation, they need a way to influence the environment. We call it an action. And then after you use that sort of action in the environment, we can call it simulation. Then something happens in the simulator, and then there's a new observation that the agent can observe, can take in, and then the agent is going to select another action and so on. So that API basically is pretty basic, pretty straightforward. And you can think of many problems that, that you can model many problems in such a way. So in reality, so even though it's, let's say, not general enough that we can just push a button and make it, run or do our laundry or whatever, right? If the problem is modeled correctly, you can do many things. Fly aircraft. We can do many things. Really.
Very cool. Very, very cool. So how do you set that space up, right, so that it can go explore? Because I don't know, it seems like a lot of work to think of all the possibilities of all the things that it could do, right?
Yeah. And the funny thing about that is that sometimes, or I would say this, like most of the time, and it just happened a couple of days ago to me too, you don't think of things, and those AIs find them. I mean, if you don't think of things, they are going to think of things. They're going to go after it, or all the little loopholes. So the way you do it is you kind of model the environment. We call it the environment. That said,
Okay.
the other side of the agent is the environment, and then so you model that environment in such a way you can use a simulator, right, to put some
Hmm.
conditions and so on. But it's an iterative process. When you hook up an agent, is going to find loopholes. Oh, I assume that the agent was never going to fly west, and all of a sudden it did, and something happened
Right.
after that, right? So those kind of things are, I think, fun to, or it's kind of fun to see the how we humans are really not perfect thinkers at all, optimal
Hmm.
in this case, in the context of reinforcement learning. We don't think optimally at all, but we've been doing okay, I guess.
And we'll take a lot of things for granted. I was sitting here thinking, I was like, yeah, if I was building the plane simulator AI, I'd be the guy that forgot about gravity, right? Because I wasn't thinking about it. And, I was thinking it moves through the air at the greatest of speed, right? And, oh, right. If we turn off thrust and we're not creating lift, that sucker's going to fall.
Yeah, yeah,
And so, yeah,
yeah.
then you look at your model and you go, oh, wow. Yeah, that's wrong. It's interesting, but it's wrong.
Yeah, and there's so many nuances that we don't realize because I'm not a pilot, so I really
Hmm.
don't know how to fly this thing. But if I'm tasked to with have create an agent that flies an F-16, then you gotta start kind of, first of all, learning things, and then when you give that AI control of the stick, the rudder, the throttle, everything, then you start going like, well, why is this happening, right? And then you have to kind
Right.
of get expert advice and be like, okay, so well, when this happens, that so sometimes the AI actually has trouble going through things that are, I guess,
Hmm.
should be basic perhaps. Or for instance, an AI does not care if the aircraft is flying like crazy unless you tell them,
Right.
you know. But I mean, oh, I'm dizzy. I mean, who cares? It doesn't really matter.
Yeah.
So even though we don't like that kind of behavior, it doesn't really matter. The AI is not trying to optimize for smoothness unless you tell it to
Right.
do so, right? And you
Right.
can use like angles. So if you bump your angles, your roll angles, and your pitch angles too much, then you get a -1, whatever it is, right?
Hmm.
I don't like that. But
Right.
but here's the very, very interesting point in reinforcement learning is, aren't you distracting your AI from the main goal, which is destroy that other aircraft over there by saying, oh, and by the way, fly smoothly. Like, I don't
Hmm.
care. Are you going to destroy that other guy or not? Right. So that's
Right.
the bottom line. And I think that our biases, so in reinforcement learning, we have an opportunity to remove our biases. Right. I think AlphaGo actually had a really was a really good example. And I think the success there was that even though they started adding biases by doing like
Hmm.
supervised machine learning early on, and kind of they call it pre-training. So they have an AI, a base AI that knows what to do. And then they give them also like, points for like well-known formations and things like that. I don't know the details exactly, but it was somewhat like that. At the end, the Alpha Zero basically had zero, or that was the goal,
Hmm.
to have zero bias and just have a self-play. So an AI basically that has no bias whatsoever as to what is a good move, or you should look at, for this kind of patterns on the table. That AI basically says, I want you to win. And in one of the games against the grandmaster, I guess there was this famous move that I even recall. I recall watching it live, and the guy was like, oh, that was a bad move. No, 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 no good, no good. And I'm like, well, it was okay, it was a
Hmm.
good run. And then later, by the down the end of that match, AlphaGo wins, and then they are like all trying to analyze and go like, wait a minute, what about that move early on? That move actually influenced the whole thing. It's like, well, humans had a huge bias there that was a bad move,
Right.
and by just removing that bias, we
Hmm.
are able to discover different strategies that are perhaps better that our own, that our own, which is sounds kind of exciting. I don't know.
It is exciting, and I remember looking at that, and the explanation that I got was essentially, yeah, that the AI figured out that it needed to make moves, and it did things that, yeah, a human just would never do.
Right.
And that's the point, is what are the things that we're taking for granted,
Mm.
within the work that we're doing that we would never ever think to do, and yet that's the answer, right? And I get excited about the possibilities there with, like, I know they're using AI in certain types of cancer research, or
Mm.
certain types of, other chemical or manufacturing processes. And I just keep imagining, okay, so what if it comes up with a physical structure for a bridge that we would never dream of, right? And then all of a sudden we have more stability, it's safer, fill in the blank. And that's exciting because it's like, oh, wow, how are we not even thinking to challenge ourselves?
Yeah. 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 And I think, I
So,
mean,
oh, go ahead.
hopefully we are. It's just that it's taking a little longer, but hopefully we are.
Yep, absolutely. So, one thing that I kind of want to get into here, because this book's like 250 pages, or more than that. But my question is okay, so we get in and we kind of figure out, okay, reinforcement learning, how does it actually work, right? Because I mean, we kind of understand this behavior in dogs or people, or whatever, but how does it work in an actual algorithm, right? How do you tell it that it's good or tell it that it's bad, and how does it, I guess I'm kind of wondering about, like, the math and the properties of this, and how it works a little bit more deeply.
Yeah. So, well, I would say, well, it's kind of hard to go, over sort of the details, right? Because I mean, this is a good opportunity to say, go ahead and
Hmm.
buy the book. I mean, it
Yes.
really, it has lots of details, and I think I go through these concepts like one step at a time, and I think that's
Hmm.
important. It's kind of hard to do it on just like audio format, but I'm still obviously gonna, talk about it. But I would say that the book actually does a pretty decent job at explaining these things. Now, I can say that, for instance, that in a kind of, I like to illustrate it what really happens, but you can think of it as the AI, right? So you can have an environment. Let's think of
Hmm.
an environment in which you reach a goal, you obtain a +1 reward, and you have other areas in which if you reach that area, you die and you get nothing, zero.
Right.
Okay. Now, in reinforcement learning, very very often we divide the sort of the trials of the agent. So the agent basically attempting to solve a problem as episodes. We call it episodes. Not always,
Ooh, I
but very
like that.
common. Yeah, it's an episode.
Does Jack Bauer save the world this time?
Yeah, exactly. So
Right.
that's episode one. There you go.
Yeah.
The only bad thing about these episodes are they're exactly the same. It's like Groundhog Day, I guess. They're just exactly the same, and you get a chance to do it better and better each time. But the sort of, well, like, you can modify things, okay, to be true to reinforcement learning. You can actually have that each episode starts slightly different, right? So you can say, the aircraft is going to start flying at 15,000 feet versus 25, right? So that variability exists there. You can do that.
Hmm.
And then so the idea is to have the agent, the first thing, let's say that, you get a +1 for destroying that other aircraft, you get a -1 for crashing into the ground, right? And then
Hmm.
the AI starts flying and gets a 0 randomly at first.
Right.
And then and you see how hard this is gonna be. Like, if you just wait, imagine that the only reward you get in life is, after death. Well, you die, and then you say, somebody really comes and says like, "Hey, you did a good job." And by the way, you have no rewards for eating burgers or shakes or anything. Like, there's nothing happy about that. The only
Right.
happiness comes at the end, or unhappiness or whatever, right? So it's pretty hard when you set it up that way. But let's continue with the example.
Hmm.
You fly that aircraft, you get a +1, you get a -1, and so on. You can start making sense of these rewards and assigning kind of sort of what we call values to different states. For instance, if I crash into the ground, I got a -1.
Hmm.
And the next time around, so I can actually start thinking, well, wait a minute. When I'm really close to crashing into the ground, that's pretty bad. I need to do something else because I'm crashing into the ground all the time and I get a -1. So I try to avoid that. Let me try something different. All of a sudden, the agent learns to, okay, let me pull up that stick and see if I can actually get off this, collision course. pull up, and then all of a sudden the aircraft moves, and then he's like, wait a minute. So it wasn't that bad. I didn't crash. It wasn't a -1. So when do I actually get the -1? When do I not get the -1?
Right.
And then you start making sense sort of backwards in that way, right? So you start propagating that value through all of your states and realizing, wait a minute, when I go low in altitude, that is actually pretty bad, especially if I'm diving down like this. That is a little bit dangerous. You should not be doing this thing. And then, you iterate like that, and that -1 gets propagated, but also the firing randomly the missile to the other guy and destroying that other
Mhm.
guy it propagates back into, the original, the initial state, what we call.
Right.
And then the agent starts making sense. Well, wait a minute. So if I fly left and then right, and then starts creating basically a strategy. That's bottom line what really happens in reinforcement learning. I mean, in this case, I guess I described one type of reinforcement learning agents. Value-based methods
Mhm.
are exactly like that. You kind of propagate rewards back. Now that's in one hand, right? The other hand would be like, well, wait a minute. So, if you as a human expert can somehow, quote unquote, teach this agent to do something such as, for instance, hey, if you're nose diving and you're 1,000 feet, that's just really bad. Just don't do that. I mean, just stop it.
Mhm.
So just mostly so that you don't waste time and this agent learns faster, because
Right.
it'll take a long time to actually get there. And in some cases it would just not propagate correctly to the agent. There are so many variables, hyperparameters in there that it just is not magic, right? So you start kind of telling them, okay, well, just avoid this altogether. You don't have to find out that crashing the aircraft is bad. I'll tell you that's bad, and so on. And you just continue to add that kind of process we call reward shaping. You start shaping the behavior of the agent in certain ways. Now, as we
Mhm.
discussed before, shaping it is basically putting your biases
Right.
into the agent. So you need to find a way to remove those biases later, or maybe use that as a pre-training or so on. There are other methods of training, sort of self-play, right? So you can have an aircraft that one is an AI and it's playing against a version of itself. And then so there's always going to be a winner there. Somebody's going to die, somebody's not going to die. And then what you do is you cycle through them basically, and then you're going to be learning much, much, much faster, right? So I think that would be a good, intuitive sense of how they actually learn in computer in when you code up an agent. It's basically that the rewards start propagating through the states, and then the
Right.
agent basically starts making sense of, well, from this state I have a chance to get this reward, I have a chance to get this other reward.
Mhm.
What is really the value of this state? I mean, because a reward is one thing, a value is another thing, right? A value kind of encapsulates the sort of long-term expected reward. So we're not
Mhm.
talking just about one single signal. We're talking about a variety of bunch of different signals that you can get in that state. So one state, when you try to summarize all of those rewards that are potential from that state, then we're talking about what its value function is, what is called in reinforcement learning. And the value function is really what the agents are in their brains, right? They're trying to calculate value functions. Again, not all agents, but for the most part, I just want to keep it simple. Value functions and policies and so on, and that way, the agent can make sense as to, okay, what do I do based on what I currently know? So if I'm in a current state and I have 5 different possible actions, right? I know that, well, selecting, in this state, selecting this action is going to give me this much. I expect to get this much reward. And this other one, I expect to get this much, and so on. And then you make sense of that. You select the action. You have a two way to go about this, right? You can select the action. And this is another very interesting thing in reinforcement learning, is that you can go after the action you think is best, right? That's
Mhm.
that's that's fair. If you are like sure that you know everything in life, then go after it, because right. But if you do
You,
not,
you you know my kids. They know everything in life.
right, like that. I do have kids too. So if you think you know everything in life, you go after it. If you think that you perhaps don't know everything, then you continue to explore. You go like, well, I don't really know. I think this may be the best thing, but let me try this one. Let's see if this one works
Uh-huh.
well. and so on. And then,
Right.
you start exploring is what we call there, right? So you start letting
Hmm.
the agent explore. I can explore selecting actions that I don't think are the best, but because I know that my knowledge is not perfect, because, it's my estimate of what I've seen in life, then I continue uh, to try actions that are currently not my best estimate.
Right.
I get a sample, I say, well, it was or it was not, right? And so on. And then you
Right.
continue to modify your behavior in that case. That makes
Right.
sense?
I, f- yep. I fired the missile 5 seconds earlier, and I got a better score basically because
Yeah.
it destroyed it faster. Or, oh, I
Yeah.
fired it way too early, and this is not the optimum way to do this.
Yeah.
Right.
It ran out of fuel. There you go. Yeah. It ran
Yep.
out of fuel. It didn't do anything. I'm now 2 missiles. The other guy has 4. I'm in trouble. Right.
Yep.
So
Yeah.
yeah, exactly so. Exactly so.
Yeah. That makes a lot of sense. One other thing that I'm wondering about, and I'm wondering if this, like everything else in programming, just basically boils down to you have to do this a bunch. But I'm wondering if you have any pointers on, let's say that I build out the environment, I put my agent in it, I tell it, okay, these outcomes are positive, these outcomes are negative, maybe you have a sliding scale for the time it takes or things like that. And then I put it in there and it's just not doing well at all. How do you start evaluating that to say, okay, I need to change the environment, or I need to change the agent, or I need to change some other factor that I'm not even thinking about? Like, how do you start tweaking it so you can get the outcome you want? Because, yeah, my experience with a lot of things like this is the first time is just going to be an utter disaster. I'm not going to get what I want at all. Right. So, how do I start getting closer to that so that I can, get an agent that's going to do what I want?
Yeah, that's a really good question. It's a pretty hard. I think that's really, where we need more people, where we need to hire more people, because it's pretty challenging, right? and
Hmm.
and the thing is, like, the actual, so you're talking about the practical side of reinforcement learning. The practical
Right.
side, that is hard. It's pretty fun to talk about rewards and things like that. And I love it when people go like, I trained this agent to do this. And then, I like I said, I work at Georgia Tech, and you go into their homework or whatever, and they have, it was just a coincidence, or it wasn't really implemented correctly or whatever, right? And you're like, man, reinforcement learning, this is unfortunate. Sometimes it works for the wrong reasons. Sometimes it doesn't work because you have a tiny little bug. And it's like,
Yeah.
it sucks. It really sucks, man. Well, so what I would say is, that comes to a sort of, a programming practice or software engineering practice. But
Right.
in this case, I would definitely, unit test, slow down, create breakpoints on your workflow, and really make sure that you, number one, I would say, first, go after the environment as opposed to the agent. Do not try to develop both, right? So just
Hmm.
copy an agent from my book, copy an agent from the web, use an OpenAI agent, use a whatever. Just do not mess with the agents at first, and start very simple. So as opposed to going like, I'm gonna get an agent with a attention net, and I'm gonna do something really cool with an LSTM, and I have so many ideas that I can do here. Yeah, okay, fine. But don't do that just yet, right? Start with the environment, kind of isolate the problem, right? So the problem is first the
Hmm.
environment, and start testing all of your assumptions one at a time, one at a time, one at a time. Boom, boom, boom. The next thing, then you go to the agent. Once you think the environment is adequate and you created the rewards the way that you think is right, and you tested it, and it makes sense, right? After I destroy it, like, for instance, in this missile example, like, how do you, like, what is going to happen when both run out of missiles? Is it a tie? Are you making that assumption? Are you actually coding that assumption, or is there
Right.
something that's actually something that you don't think of at first? Wait a
Hmm.
minute. They both run out of missiles. They could. Yeah.
Yep.
Okay. Well, okay. How about when they both crash exactly at the same time? And you may say, no, that's impossible. Well, it's possible, especially when you run millions and millions and millions and millions of episodes, right?
Right.
Then it is possible. What are you going to do in that assumption? Well, I don't know who wins. Does blue or red, or no? It's a
Right.
tie. Okay, well, okay. Make sure you have that assumption and write a test case, right? That actually tests exactly that. And like that, right? You go over all of those kind of basic assumptions first when you create the environment, and then you move to the agent side, right?
Mm-hmm.
And in the agent side, you have a fixed, quote unquote, fixed environment, but we know that it's not going to be right. At least you start tweaking the agent and creating the models that you want. If you're doing a deep reinforcement learning agent, then add the networks that you want, cut them up, make sure that is valid, whatnot. Test that same agent in different environments, not just in yours, in different
Mm-hmm.
environments, and see the performance of that single agent in the different environments. And then, pair it with your environment and start tweaking the environment and the agent at the same time until you get it the right performance. Because yes,
Right.
we're not perfect. We're not going to create perfect rewards at first time. And I can assure you that the first time that you create reward functions, it's just you don't think the same way, or in a
Mm-hmm.
mathematical sense. You can, the agent at one point is going to be like, oh, that action is good, but it's like 0.0001 better than the other one, or worse
Right.
than the other one. And you didn't see the 0.0001. I mean, it's just not going to happen in your brain.
Right.
So those kinds of things you can adjust then in that second phase. And then the third phase will be the training sort of mechanism, right? Because this agent could be good, but you may be creating like different versions of your agent, and then
Mm-hmm.
testing multiple versions of your agents against each other, and so on. And then there's some training mechanisms, and this is actually very interesting in reinforcement learning. There's such a thing as curriculum learning, right? Which
Mm-hmm.
basically means sometimes your agents, the problems are so hard that it doesn't make sense for you to go after the big thing straight, right? So you're not going to drop off your baby at the university or at an office and say, hey, go ahead and,
Mm-hmm.
have a job. No, it doesn't work that way, unfortunately. I know
I
you want
was
to
going to
drop
say
them
that'd
off.
be nice.
There's such a thing in reinforcement learning called curriculum learning, and curriculum learning is sort of like a big umbrella that you can think of. There are multiple little branches, such as there's something called self-play, which is basically what
Mm-hmm.
I mentioned of a version of yourself. There's also something called league play, which is what the folks at DeepMind and OpenAI use for their agents. Basically, I don't know if the OpenAI, that I'm not 100% sure of that, but I know that the DeepMind folks did that. The Alpha Star basically had a league of multiple different AIs, and also different agents that kind of exploit behaviors that they found AIs would converge to. And then so you can have a league strategy so that your AIs are really, really robust and good against all types of agents and so on.
Mm-hmm.
So I think that pattern is a good one in the practical sense. You first go to your environment, then move to your agent, then go to the training, and obviously you're gonna have to go down, up and down the pipeline multiple times. It's not a one thing, but if you do start without touching any of the rest, you have trust me now, you're gonna have a better time, and it's gonna be better.
Yeah, it makes sense.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Yeah, I remember I took an AI class in college, and yeah, we were using all these algorithms just to find kind of the optimal path for a tank, and then when to turn and when to shoot and all that stuff. And boy, this would have been kind of fun to dive into with that. Yeah.
And then you have that AI class. You remember if it was like quote unquote learning, or it was more like a search type of algorithms? I mean, in the AI classes, they teach both, but I wonder if you remember. Do you remember? No? Yes?
Yeah, it was mostly just searching, and yeah.
Okay.
Yeah.
Like a
I mean,
yeah. Yeah. So, and interestingly, AIs or reinforcement learning AIs can actually use those kind of search methods as well as, to kind of be better. Some of these you can think of it as some people call it model based, right? So
right.
you basically learn a model of the environment, the dynamics and so on, or, you're perhaps given that in advance, but that would be, to me, a sort of planning method as opposed to an actual learning method.
Right.
But, you get that, you learn the model, and then you use that search algorithm, and they're pretty similar. They just do that, search through all of the possibilities, and then, modify your behavior based on that search.
Yep.
Now, without taking the model-based reinforcement learning methods, do not just rely on that search method, right? They use the search method to kind of guide their path, but they do continue to explore as opposed to go through the quote unquote optimal. Why? Well, because they know that the model is not perfect. They just learn
Right.
that model and so on. So yeah, cool.
Yep. Yeah, I'm kind of digging this. I want to go play with it now.
It's cool. It's cool. It's addictive.
Do you have
Terrible.
yeah. It's all addictive.
Life
it's
is
crazy.
right. It's good.
Yeah. So I'm a little curious. Do you have some favorite models off the web that you recommend people start with? Or
Okay. For
yeah, I guess you
recommending,
can pull some out of the book too, right?
yeah. So I do have, I provide, so, okay. For people to start playing with that, I recommend the ones in the book.
Uh-huh.
I try to make them all in the same sort of one function. So
Right.
I try to make it easy for learning, right? So that was the purpose. Now, if you
Mm-hmm.
want to do it for like performance or after you learn the algorithm and you want to like, move on to something, high good implementation, I do not recommend. Obviously, the ones from the book, they are not meant for
Right.
production quality. I recommend though, RLib is actually, it's come to be it's a library, RLlib.
Mm-hmm.
It's a pretty good library, and they have not only really good implementations, but what I do like of their code base is that you get to use. It is pretty easy to kind of have a distributed learning system, and when you get to
Mm-hmm.
really challenging problems, there's not such computer that can just train your agent at once. I mean, you need multiple computers, and each component of the agent is going to be residing in different computers,
Mm-hmm.
and those computers are going to be optimized for the particular part of the agent. So the agents are no longer inside of your computer; they are distributed, right?
Right.
And in this case, it's actually really good. I actually think that they have implemented a pretty good package. I mean, it has bugs, and obviously, but I mean,
Mm-hmm.
super complex library. So it's not perfect. I guess is what I mean, but
Mm-hmm.
it is definitely to me, the best so far. So I would recommend the ones in my book actually has actually, you don't even have to buy the book for that. You go to the GitHub repo and check it out. It's Mimoralea. That's my handle. And you can find me there in Twitter, just basically everywhere. And then GitHub. So GitHub, Mimoralea, and then
Oh, I found it.
/GDRL, Grokking Deep Reinforcement Learning, GDRL. And just grab some algorithms there. Now those algorithms, in the early chapters are very simple, and the idea there is to kind of like that get build the intuition, right? This is what it is, and so on. And then as we move forward in there, yep, that right there. So as we continue, then the algorithms get more and more complex, and you do have the sort of quote unquote deep reinforcement learning, which is just a fancy word to say, neural networks with a bunch of neurons. I know I would
Mm-hmm.
be, some folks are like, no, it's more than 3 layers, or it has to have this many nodes. I don't care, guys. Sorry. I just say if it has a deep network or a neural network, sorry, I call it deep. That's fine.
Mm-hmm.
Though in my book, I try to make 3 layers so to please some of those guys. Well, 3 layers with one hidden. Never mind. Maybe I didn't. Anyway, I was thinking of those guys who have a laptop and are like gonna train this thing, and they have to take like 5 hours to train or something like that. That's not fun. So I try to make them not as deep, but you can obviously add layers if you like.
Yeah.
But yeah, that's where to find. I would recommend those two resources.
So one other thing that I'm a little curious about, because you're watching this and we keep seeing new advances in the arena of AI or machine learning. Are there changes that have happened since you published the book, or changes within the reinforcement learning arena that you see coming down the pipe now that you're excited about?
That's a good yeah. Well, so unfortunately and fortunately, this is a very fast moving field. And
Mm-hmm.
yes, I mean, many of the algorithms are no longer quote unquote state of the art. Okay. Even
Right.
PPO has been, the kind of like the best algorithm for a long time. You have now the FASIC policy, whatever. And so they continue to change and improve. And that's a good thing, but it's a bad thing. That route for it's a bad thing for the newcomer, right? But that being
Uh-huh.
said, in the book, I try to focus on the things that do not change. And I think I did a good job at that. And yes, you're gonna learn about your fancy algorithms, A2C, A3C, PPO, factor critic, da da da. And those are fancy. And by the way, we're still using those algorithms. Those are really good algorithms.
Right.
So they're not bad. They're not old. They're just not the best. Or you know, in the sort of default form, you do have to
Hmm.
embellish these algorithms to make it the best. Okay,
Right.
but their basic form, those algorithms are pretty good, pretty decent, and so in the book I try to distill the knowledge of what we learn from these algorithms, as opposed to this is the way to go with reinforcement learning. I think I did an okay job with that. Now I'm going to say that there are areas that I think are you know well, perhaps, well, I don't know, I guess I would say the sort of learning strategies
Hmm.
are things that people started paying attention more recently, as opposed to the actual algorithm.
Right.
Like for instance, the OpenAI folks, they achieve great performance at their Open Five with their Open Five
Hmm.
agents in the what is it, Dota 2, I guess it's called the game. I haven't
Yeah.
played this game, but Dota 2. And they used a version of their PPO algorithm with a little fancy network. So again, it's very vanilla, very standard
Yep.
agent, but they use a different kind of training strategy, right? And they concentrated on the sort of systems engineering and more like the engineering of the training,
Hmm.
right? How can we best train in 1,000 servers? How can we scale up this agent? And also, when we have multiple agents, how do we make sure that learning actually progresses towards what we want? Like if you start playing in a band, right? You have five
Hmm.
musicians, and none of you guys know how to play their instrument, and you guys start learning all at the same time. It's a little bit messed up. I don't think that there's
Yeah.
gonna be good learning. Now if you have a drummer that is good, and the drummer is keeping your tempo and stuff, and you're learning bass, and you go like, okay, and but the drummer helps you by being static and not learning. I'm telling you here what
Right.
multi-agent systems usually need that kind of stuff. You freeze everybody else, and then you have one agent learning at a time, right? So that it can
Uh-huh.
get really, really, really good learning progress. I mean, they could learn
Hmm.
with non-stationary environments, but it's much harder. So those kind of strategies, I think that's really where a lot of let's say a lot of the money, but figuratively. Well, I mean, if you want to get a job, probably not figuratively, but anyway, a lot of the progress going forward is going to have to go towards that, towards
Right.
ways that we can make these same agents learn better and faster in our particular problems.
Yeah. Well, it's interesting. I mean, you brought up Dota 2, and I think I haven't played it either, but I imagine from the people that I've talked to about it that it's something like League of Legends. So you have a team of players that are trying to beat another team of players.
Yeah.
And yeah, so I would imagine the same thing, right? Assuming that the other side does the same things every time, right?
Right, right. They're not,
And
yeah, they're not learning while you're learning.
right. And that the other agents on your team also are doing the same kinds of things every time. Then you work through multiple scenarios where, they all do the same kinds of things over and over and over again. Yeah, then you can learn how to counter certain types of strategies coming from the other side and how to reinforce strategies on your side.
Yeah, yeah. And by the way, so I see a real Salt Lake. I suppose you're a soccer fan, maybe not. I
Yes.
don't know. Yes.
Yes.
Okay. Well, so it happens in soccer too, right? So you practice, you go to practice, you practice, right? And
Hmm.
you're gonna be practicing strategies and free kicks and everything. You
Right.
practice during practice. You don't practice in a match. You don't
Right.
go and go like, oh, I have a great idea. Let's do this different tactic right now in the final. No, you don't do that. That's stupid. Don't do that.
Hmm.
Go practice during training, right? Prepare for the matches by
Hmm.
fixing different things so that your learning can increase, can progress.
Right.
And then you use that learning and then use it to perform. Now you can adapt
Hmm.
during your performance, right? But I don't think I think you can learn adaptation. Adaptation doesn't have to be
Right.
just learning, right? And changing your style. So
Right.
that kind of stuff is it's another way to see it. Yep.
Yeah, it makes sense. And I kind of think of this as watching tape. My brothers played football. My dad would get the tapes and he'd sit with them, and
Yeah,
and yeah, a
exactly.
lot of times it was look, if you had just been, half a foot to the left, right, you
Right.
would have blocked better. Or if you had just, come up just a hair faster, you would have beat that guy off the line. And right, same thing in
Exactly.
soccer. And soccer's my sport. That's the one that I love to watch, right? And so yeah, if you'd gone up against that guy for the head ball, a split
Right.
second sooner or later, right? Or if you had been a little bit more aggressive, right, to get him off his line, or things like that. Yeah, you can start tweaking it and letting people know, okay, you don't have to completely change the style of play that you have, but if you push it a little bit more this direction, you're going to get better results.
Right. Right. And it's exactly the same type of learning. I think so. Well, future advances, let's say, should come, but I think definitely there has to be more movement there, because that is definitely where we're lacking. I mean, I'm sure definitely
Hmm.
there's ways to improve algorithms and so on, but I think we got that one at a good stage right now, that we need to continue working on the sort of how do we best train these guys, and then sure, iterate and get better guys and so on. But at this point, I think we're in the training mechanism, especially for multi-agent. I think that's that,
Hmm.
because that's where we're, I guess, early on in reinforcement learning, 2015, I guess those years, everybody was creating agents only, and they weren't really, well, people are going to kill me for this, but that's okay. Deep reinforcement learning, well, because multi-agent has been around for, like, the
Yeah.
50s, the 30s,
Yeah.
whatever, but that's
Been
all
been
right.
around forever. Yeah.
But yeah, deep reinforcement learning in particular, agents have been trained in single agent environments for a long time. And it's just recently, 2017, 18, and well, I guess we're 21 already. Holy cow, we're getting
Yeah.
old. Anyway, so recently, quote unquote, 3 years, 4 years ago, that we started, training agents, the same deep reinforcement learning agents in multi-agent environments,
Right.
with an opponent, with a collaborator, or with teams, right?
Hmm.
So that makes everything much more interesting.
Yep. Makes sense. All right. Well, let's talk about the book for a minute. So if I go and pick up your book, how should I approach it?
I, maybe people don't like this, but I recommend front to back. Like, I really try to do a good job at going baby steps at a time. It is not project
Hmm.
based. I'm not trying to go like, oh, let's now build an agent to, do the stock market, because not everybody cares about the stock market. And
Right.
I think so. My intention behind the book was to kind of distill the kind of basics of reinforcement learning, so that you can go and then apply it to your particular problem, as opposed to me going like, I'm not going to explain any of the details. I'm just going to plop a bunch of code and tell you this code is for an agent that trades in the stock market. I think that's cool. Don't get me wrong.
Hmm.
But I didn't want that to be my book. I know there are other books that are project based, but I like to have a sort of, let's say, self contained material. And I think my book does a good job at that. If you get that book, you're gonna open the first pages, and it's an introduction. The first chapter is probably the only chapter that I would say skim through it is kind of like a required chapter. You have to talk about the history of reinforcement learning and when is good and when is not. So you already have an idea. That's fine. Just move on, or skim through it. Look at the little kind of tidbits that I placed all over the book, and then after that, chapter 2 on, just read it, sit, and be
Yep.
comfortable. My recommendation is you read the chapter, then go and play with a notebook. I have a notebook that runs top to bottom. Every single little code snippet in the book is in the GitHub repository. All the code is there in one notebook, and it runs. I mean, you play from top to bottom and it runs. So my recommendation there is, run it, and then perhaps, start making changes and seeing what the algorithm is really doing. How is it learning? Perhaps create plots, right? That can give you a better intuition as to this is what's really
Hmm.
happening, right? But I try to create plots in there and put them in the book, so that that kind of stuff is there. But I'm not the best data scientist at all, not at all. So you're a data scientist and can create cool plots. Go ahead and do it. Share it. Have others look at your plots, and that kind of sort of I don't know, maybe silly word, collaborative learning experience, but I really mean it. Like,
Hmm.
other folks can do better at plotting. Go ahead and plot and do that. And like plotting, there's many other things that you can do. And then my advice is go after one chapter and then think of what can I do if you really want to learn. And just what can I do, from this, and what can I share with the rest, right? And go do it. That
Right.
little exercise is gonna get your brain into it, and you're gonna kind of like get material,
Mhm.
into your brain, and then so on. You just keep moving through the books. The book, for those who read it like that front to back, so there are tidbits that kind of try to repeat and reinforce, well, reinforce, lack of a better word, reinforce the material here and there. Those are, designed with a purpose to give you a break, to, make sure that you bring concepts that you learn in previous chapters into that chapter so that you can see the relationship and the chain of knowledge as you go and move forward. And yeah, I would say that. I don't know. I mean, I don't know if that answers your question at all, but I think that is how I would approach the book, definitely.
Right. Yeah, it sounds a lot like the advice that I've gotten from another friend of mine who I've interviewed for the Clean Coders podcast. And yeah, I was like, well, how do you learn a new thing, right? Because he was like, so I learned Swift and I do iOS development. Then I went and learned Android and I do Android development. And I'm like, well, they're pretty different. So how do you pick them up? And yeah, that's what he said. He's like, usually he just reads through the whole book one time and then he goes back through and implements all the stuff in it.
Oh, or
And
that's another good approach. Yeah.
right.
But yeah,
But it's the same idea.
well,
Yeah.
what I think about it is like if you're let's move from the mental realm to the physical one, right? So if you
Hmm.
want to gain muscle, how do? You first have to eat a bunch. I mean, you have to feed your
Yep.
body with quality food. Okay, so if you're
Yep.
just going online and just
Big
getting whatever
Macs.
you can get, yeah, Big Macs. That's Big Macs. Do not get Big Macs. Get good material. Look at
Right.
where the material is coming from, and then feed your body well. Now, usually in my personal experience, I cannot just eat and go work out, or work out, and
Right.
it just doesn't work well. So you don't have to do the two. Go read the book. In other words, is what I'm trying to say.
Hmm.
Go read the book, and then later, wait a week or whatever, and then actually get to the code and try to implement it. All of that, and also if you kind of cycle through those, better results. It's very similar. I don't
Yeah.
want to stretch the analogy, but it's very similar. You gotta feed your mind the proper amounts, plenty, proper
Hmm.
amounts, and quality, you know,
Right.
foods, put it that way.
Uh-huh.
And then you also have to exert. If you don't
Right.
exert, if you don't go and try to do it and kind of get yourself to do it, I know that's the hard part, but if you don't do it, you're not going to learn. You're going to be
Yep.
philosopher, or
Yep.
it's just not going to work. Sorry, it's not going to work. But if you want to learn, that is it works every time. That's the
Yep.
beautiful thing.
Yeah. It's funny that you brought that analogy to bear because I just barely signed up for a training program. I've decided I want to actually go do an Ironman. And so
Oh my
I,
goodness.
yeah, so I bought this training program, and the training program comes with videos, right? And
Yeah.
so it walks you through, okay, here are the concepts you need to know. Here's how you think about your training. Here's how you eat. Here's how here's what we mean when we say do this in the pool. Here's what we mean when we say do this on the trail when you're running. Here's what we mean when we say do this on your bike. And yeah, I mean, you have to understand what all of this means, and then you have to go and actually, you have to feed your system the right way, eat the right stuff. And yeah, you've got to go out and do the work, because if you don't, then when it comes time to actually go run the race, you're not going to be able to do it.
Yeah, yeah. And it's super, super interesting because I even, the analogy, you can stretch it, but I would say that you can actually get, mind fat, right? You can actually get so
Mhm.
much information that you just cannot move. You're like, okay,
Yeah.
that's
What about
it.
this?
And
But
then
what
you go
about
like,
that?
let me watch another video on this
Yeah.
just to make sure I got it right. That's it. You're mentally obese, right? Which is
Yeah.
fine. I mean, we're humans. I'm not, you just like,
Yeah.
I'm actually like 30 pounds after this 2020 craze
Mhm.
lockdown year, right? So
Yeah.
I'm guilty, but I'm saying that it does happen. It's very interesting, and mentally it also happens. People start going like, one more paper, one more video, one more. No, that's not how it works, guys. You read, one thing, watch one video and then you go into the insertion phase, which is the hard one. But when you break through that inertia, the very first little bit, like putting your hands in the keyboard, that's it. Success after that. Because it doesn't matter. Once you start typing, your brain starts going, okay, now let's go. Move.
Yeah.
Anyway.
All right. Well, no, it's all good. And I think it helps to kind of get people to take action, which I think is the important part. So I'm going to put a link to the book in the show notes. I do have a coupon code that gets you 30 or 35% off. I don't remember. If you go get it from Manning, and they'll actually send you the ebook, right? You can't get the ebook on Amazon, which is my favorite way, because then I have a bazillion books in my pocket, right? If I'm stuck somewhere, I can go read one. But yeah, that's the way to go, in my opinion, is to go get it from Manning.com. So yeah, we'll have the link. We'll have the coupon code. Look in the show notes in your podcast app, or come to the website and get it. And let us know what you thought.
Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams, or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming, and I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit, and you can find that at summit.mostvaluable.dev.
Miguel, we do have one more segment of this show, and that's picks. And the picks are essentially just shout outs about stuff that you're enjoying, or, are a good thing in your life, or things like that. I'll go first, and you kind of get the idea of what we're talking about here. So I have 2 picks, and the first one is, I've really been enjoying The Expanse on Amazon Prime. So if you're into sci-fi shows, it is extremely well put together. If you've read the books or listened to the books, in my case, I listened to them on Audible. The books are amazing too. And anyway, I really, really, really enjoyed the books. A friend of mine actually tweeted the other day. He said, "Who's your favorite character from The Expanse, and why is it Amos Burton?" And it's funny because most of the responses were, "Oh, well, yeah, it is Amos, right?" And it was funny. We had a little bit of a conversation about, Amos is my favorite character just because he's so interesting, right? In the way that he acts, and his motivations are so different from anything that I would do, because he's a psychopath. But the flip side of it is that I really, really strongly identify with James Holden. And so, we had the conversation about that and what that meant and all that stuff. It was kind of fun. But anyway, it's a great book series. The characters are awesome. I think that's what they missed the boat on with the latest 3 Star Wars movies, is that they didn't give the characters a rich enough feel. And so people don't identify with them the same ways they did with the original Star Wars movies, because the technology was cool, but you really cared about the characters. Anyway, I'm getting way off on a tangent, but I'm going to pick The Expanse on Amazon Prime. And then the other thing that I had a really great experience with, and this is something that you all can sign up for, is I started a coaching program, and I'm coaching people on how to become what I'm calling dev heroes. And what the idea really came out of was, I talked to a whole bunch of people that were kind of stuck at senior developer, right? So if you talk to juniors and mid-level developers, they're all going, I want to be a senior developer. I want to be one so bad. And then they get there and they're not really sure where to go from there, right? So they have that job for a year or two, and they start thinking about, okay, where do I go from here? And some of them wind up in management and they're happy there. But some folks, they look at it and they go, I don't want to go down the management track, right? And I also don't want in 3 years to be in the same job, maybe at a different company, right? I got a high from learning, from moving forward, things like that. And so I want to find that again. And that's what I'm creating. What I found is that if you go out and you start producing content and networking with people and things like that, right? Like we're doing here with Miguel. I like the guy. I've gotten to know him a little bit. We've had fun chatting. I can probably ask him to come back on and talk about something else, or, so I get and I've learned a bunch, right? And so I get all of that payoff, right, from doing this. The other part of it is that some folks are trying to either build courses or build a freelance or something like that. And it's also a great way to kind of do that, right? And so maybe your high is, oh, I just made another couple $100 selling a course, or I just helped another person with my content, or I met somebody that I can sit down with for a half hour and I can help pull them up, right? And so I'm trying to help people create positive things out in the community, but then also be able to profit from them either monetarily or emotionally or whatever. And so that's the idea behind the Dev Heroes. So if you're interested in learning how to do it, then you can go to devheroesaccelerator.com and it'll take you to an application. You can just fill it in. It's mostly questions about where you're at and where you want to get to. And then from there, if I think you're a good fit, then I'll get on a call and we'll actually do a 1-hour strategy session. We'll talk through where you're at, talk through where you're trying to get to, and see if you're a good fit for the accelerator. So I'm not letting everybody in. If you get into the accelerator, it's because I think I really can help you. Otherwise, I don't want your money. I'd rather have you, move in a direction that's going to make you happy and not pay me. So that's kind of where we're at. So yeah, devheroesaccelerator.com is where you get that. Miguel, do you have some things you want to shout out about?
My goodness, I suck at this. I won't be able to do it for 5 minutes, but I can.
I talk all the time. That's my gift.
Okay, that's your gift. Definitely. I'm like, I don't know. Did I watch? I think I watched a movie last night. What was it, Thor or something? I don't know. My wife liked that guy. Go. Should I shout it? No, that's ridiculous. No, I'm not gonna do that. I'm not gonna do that. However, because it's reinforcement learning, I know I need to do one though. I would say so. I think the lectures by David Silver, by Sergey Levin, and then I think there's a new one also coming up, Dmitry Berksitas. They are posting their lectures. These are high quality instructors, and they're posting their lectures on YouTube for free. Obviously, I mean, it's YouTube, right? So, I mean, for free, quote unquote, you watch advertisement. But other than that, it's pretty good. So, I think that's the shout out that good job. I mean, they are doing not only a good job by, just posting these lectures there and, having it accessible to anybody, but, these are, MIT, Berkeley professors, DeepMind, I guess is the UK of London, whatever. I don't know what the university is in there, but I would highly recommend that for those who want to continue learning reinforcement learning. And I would say, yeah, that movie, that Lockheed guy, he's fun guy. I mean, I like this guy. He's
I know,
ridiculous. Right? I had not watched this guy, but I mean, this is like fun stuff. This guy is crazy. My wife was laughing her ass. It was awesome. It was great. But anyways, it's an old movie. So, but I have little kids, so I haven't watched. I need to catch up. I haven't watched movies in like forever.
I know, right? My wife and we do a date night every Wednesday night. So we'll watch a movie or we'll
Your kids are
play board games. My youngest is 5. My oldest is 15. So yeah.
Oh, so you're okay.
So we have the spread.
My oldest actually.
Oh, so you guys are busy.
Oh my gosh, we haven't watched a movie in years. And then so yesterday, actually, in years, but we watched actually yesterday, last night. We're like, oh, let's just do it. Let's do it at night, right? And yeah, we watched that one. It was fun.
Yep. Yeah. No, I remember those days very well. I have 5 kids, and yeah, the oldest is 15, and I have a 13-year-old, a 12-year-old on Saturday, and then or Sunday, her birthday's Sunday. Her birthday's on Valentine's Day. That's Valentine's.
Actually, mine is the 15th. That's fun.
Oh, wow.
Yeah. Mine is 15
Happy
in the
birthday.
morning. We were like, not Valentine's. That would be double present. So you have one coming up. That's great.
Yep. And then I have a 9-year-old and a 5-year-old. So yeah, fun time.
Wow. Good.
All right. Anyway. Well, let's go ahead and wrap this up. Thanks for coming, Miguel. This was really helpful, really interesting. And I love just diving into this stuff. Before we do that, I guess I should also ask, like, where are you on social media? We have your GitHub link, but anywhere else?
I was very, I guess Twitter, but not quite this year for some reason. I've been a little bit more like careful with the power of the Twitter. But that aside, if I check once a week or 2 weeks and so on. So I think social media, that would be it. And I try to remove myself from every other social media actually just recently. I'd rather more like sort of, instead of socially meeting people, getting to know one-on-one, I guess. And, if folks want to send me an email, by all means, that can happen too. So, and that would be my same handle at gmail.com. Just send something, say hi. It's all good. It takes me a while to respond. I'm not, all the time checking social media stuff, but that's what we got so far.
All right, sounds good. Well, we'll put links to all that stuff in the show notes. And thanks again for coming. We'll wrap this up, folks. And until next time, max out. Yeah.
Thank you.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.